Hello and welcome to another video. In this video we're going to be working on robot collisions. And I feel like I did this in a LeetCode contest a while ago, but we're going to be doing it again and we're going to be doing it in Java. So in this one there's n one-indexed robots. Each has a position on a line, health, and a movement direction. So you're given these things. So the position is the position on the line, the health is the health of the robot, and the direction is if it's going left or right. And the robots start in the line simultaneously and the same speed and the given directions. If two robots ever share the same position, they will collide. If two robots collide, the one with the lower health is removed and the one with the higher health loses 1 health. Your task is to determine the health of the robots, survive the collisions in the same order that the robots were given. And the final health, so yeah. Or if there's none, return an empty array. Return an empty array, or return an array containing the health of the remaining robots in the order they were given, and no further collisions can occur. The positions may be unsorted. So this is very similar to like asteroid collisions or some other things, but the main thing you have to do is you have to return the health of the robots in the same order they're given, and the order they're given isn't necessarily in order. So normally it's like in order, but here, here for example, they're backwards. So like this first robot is actually at the very end, and so on. So one trick you can use is if you want to sort positions, but you want to maintain like where the things were, so you know like where they originally came from. It's pretty easy. There's a few ways you could do it, but basically what you can do is, so if you have an array, say we have an array of positions, and I guess we'll have actually, yeah, I think this is an easier way to draw it. So let's say we have this array, and the positions is like 5, 4, 3, 2, 1. So we want to sort this array, but we want to make sure that like after we sort it, that we still know where 1 was in the original array. So we know like 1 was at index 4, 2 was at index 3, and so on. So what you can do to do that is you can simply, instead of sorting like this, you can simply make a tuple of the position and its original index. So this would be like 1, 4, this would be like 2, 3, and so on. So let's pretend this index above is actually in this array. And then when you sort, it'll basically be backwards. So, whoops. So it'll basically be backwards, so it'll be like 4, 3, what am I doing? Okay, so 4, 3, this will be at the end, this will be over here, 2, 1, 0, right? And so you're gonna have every array will just be a tuple of this. And then that way, like, you know that like this is the first number, but its original index was 4. And then when you get these results, you know exactly like where they were. So you can just do that. But actually we need a few more information. So we need the position and the health and the direction and the original index. So we're going to have like an array of 4 items. So for everything we want to sort on position. So we could have like position, health, direction, and original index. And then we can sort based on position. And then this is how we can go through our robots. Because we want to go through our robots left to right, kind of like the asteroid collision. You want to go through robots left to right, and then you want to like see if they collide. And if you think about it, if we go into robots left to right, the only way you can collide is if you have a robot going right, that you have currently, and then you run into a robot going left. That's the only way they can collide. Any other thing won't collide, right? Like if they go the same way, like if they have left, they'll never collide because they're moving the same speed. This is not collide. And if they go like this, they are just going the other way, and they will never collide. So basically, we can just use a stack, and then we can have a few cases. So one case is, let's say our robot is going left. Like, let's say a robot, like, I'm not going to show any of this, I'll just show a bunch of robots. So let's say we have like left. I don't know why I'm also drawing the left backwards, but let's say we have left, and then like right, or something. So if we have we're going to use a stack, just like the asteroid collision and all that other stuff. If we have nothing in our stack, so let's just show a stack. Here we go. If we have nothing in our stack and we have a robot going left, this left robot won't collide. We'll just simply say like some HP, and then we'll put the direction in. So we'll say like whatever HP, and then left. Yeah. And then that will work. And then whenever we run into another robot, we just check like if that robot's going left and this robot's going left, those won't collide. So we can just add in another robot going left. So I'm just going to show the left, but we'll have HP, and then we'll have the direction, and we'll have the original index, because that's the information we need. And I'll kind of show all that. So the only way we do collide is if we put in a robot going right. So anytime we have a robot going right, we can throw it into an array, because the robot going right now can't collide into anything else, right? Because no matter where these are going, this will not collide with them. If these are going left, they're going the other way. If they won't collide, if they're going right, then they're moving the same speed, so they'll never collide. So the only way you can collide is, like I said, this. Not that. This. So basically, all we need to check for is if we have a left and a right, and our last guy's a right, then you have a collision. And then for there, you just simply check which one has more HP. So for example, let's say this left has more HP, you would just pop off your last guy, modify your left HP, and then you would compare with this. And as long as you don't have the left and a right, you can't have a collision. And then you will just simply put in your dude, whoever survives. So like maybe this survives, so we'll put it in. And that's all we need to do. And then at the end of the stack, we'll just have a bunch of robots with HPs. We'll have HP, we'll have direction, and we'll have original index. And then from HP and original index, we can just fill out this whole thing, right? So we can just sort on original index, and then we'll have them in the order they were in originally. So let's walk through that in this whole full example. Okay, so for every robot, we're gonna have the position, the health, the direction, and the original index. So let's just do this. So for the first robot, it'll be like 5, 2, right, and original index is 0. And we're gonna have 5 of these for example 1. Yeah, so 4 more. So the next guy is at 4, 17. I think they're all going right here, right, and 1. Next guy is 3, 9, right, 2. Yeah. Next guy, so let's maybe move it over here a bit. Or you can make these a bit smaller too, than to be this big. There you go. All right, so 2 more. So this guy is 2, 15, right, and 3. This is 4 and 4, or sorry, this is 1, 10. Okay. So these are this is the original positions of the robot, right? So position, we can write this up here. So position, health, direction, original position, just so we can remember like what we have. Then we're going to want to sort these based on position. So basically this will get reversed. So this will go here, this will go here, because you want to go left to right. I guess maybe you can go right to left as well and just like reverse all stuff. That would technically work, but left to right, I guess like more intuitive. So now we have them left to right by order of starting position. Okay, then we're gonna have our stack. So we don't need an index for the stack, we just need a stack. Maybe use this so these can fit. So let's say the top of our stack is actually, yeah, I think this will work better because then these can fit easier. Let's maybe do something like this. So let's say the things come in here and then go down. Okay, so we start here. So this guy is like there's nothing in the stack, so we just put him into the stack. Pretty easy. We don't actually care about the position though at the end, like because the positions are only relevant to go through your array. So these positions actually don't matter, so I'm just gonna get rid of them. So we're gonna sort based on position, but then we don't actually use it ever again. So be like this. And yeah, so we just have health, direction, original position. Because we're not gonna use a position, like because things are moving at the same speed, doesn't matter. So first guy, we don't have anything in the stack, so we just throw him into the stack. Let me make it a bit smaller. Okay. Now we're into the second guy, and basically the only time we have a collision is if we have a right here and we have a left here. If this is right, we just keep throwing into the stack. So basically what will happen here is you'll just always throw these into the stack. So this will go in, this will go in, this will go in, this will go in, and this will go in. Then you sort your stack based on the starting position, so it'll basically be reversed. And then you just write down the HPs. So it'll be like 2, 17, 9, 15, 10, which is that. So that's example 1. So let's maybe throw out this guy, delete all these, and let's go through example 2. And we're just gonna, to speed this up, let's just sort them on position. So we're not gonna include position, but we'll just have them things sorted in position. So let's do that. Let's move all this down here. Can even get rid of this, don't need it. Okay, so our first thing will be, like I said, sort on position. So this position is first. So it'll be, and we don't care about the position, so it'll really be health, direction, and original position, which is 2. Then the second guy will be this guy. So health, direction, original position, 0. Third guy will be at index 1. So health, yeah, that's fine. Left and original position 1. And finally, last guy's at the end. So health, left, 3. Okay. This is how to sort our positions. So now we kind of do the same thing. We just start over here and we go through this. So first, there's nothing in our stack, so we can just put our thing in. So that'll just go in. If I can get it, maybe I can't. Oh, for some reason they're together. Interesting. Okay, so you're gonna put that into the stack. Next, we're gonna have this. And like I said, you're only looking for a left, and the stack has to be a right. So whenever you have a right, you can just put it in. So we can take this guy as well, put it into the stack. Because you can't collide until you have a left. Okay, here we go, we have a left. So we have a left, and we have, this is our stack, we have a left and right. So the one with most health survives, and they have the same health. So they just both die. And then we can move on to the last guy. And the last guy is also collision, and the one with most health survives. So this health survives, this health dies, and this health gets reduced by 1. So 14, this guy dies. And so you only have a 14. That's example 2. And then example 3 is going to be very similar. So yeah, so we can do that one quickly and then we're done. But yeah, basically all you do is you just check, do I have a left? And if I have a right at the top of my stack, then I have a collision. Figure out which one lives. And if your left lives, you keep checking the top of your stack. So for example, let's say we have a bunch of these. Like let's just say, obviously this index will be wrong, but whatever, let's ignore it. Let's say we have a bunch of rights and our left, we run into a left and the left has like 50 health or something, right? We have a left with 50 health. So what will happen is it will kill this guy. It will kill this guy, it will kill this guy, and kill this guy, and then we would put the left in. So you keep doing it until the thing you're trying to put in is dead, or until, also, like I said, if the top of the stack is left, and we're putting in a left, then we won't have a collision. So one of those. Okay, so let's do the last one really quick. Okay, so the position, looks like these are sorted, so it's going to be easier. So 10, right, 0, and then 10 left 1. Let's move this. And then 11 right 2. And finally 11 left 3. Okay, so same thing as before. We go left to right. Yeah, I guess this is probably better to draw a stack like this. It makes it more clear, so I'm gonna probably do it in the future. Okay, so here we have nothing in our stack, so we just throw this guy in the stack. Right. Then here we have a left and we have a right here, so there's a collision. So their health are the same, so they both die. So this is dead, this is dead. We go to the next one. Nothing in the stack, we put it in. So put it in, and then here their health are the same, so they both die and there's a collision. So you just return nothing. But that's basically it. So it's not super hard, pretty easy problem to be honest. And the only tricky thing is how do you maintain the original index? And that's the thing that you can do is just throw in the original index into the array of all the combined stuff and sort by position. And then you have that variable to know where you came from. Okay, so let's look at the code, and I just had it coded beforehand. Something I do when I'm kind of lazy is like I can write this in Python way faster. So a lot of times I'll just write it in Python and then just GPT convert it to Java. Usually I don't. Like usually I just write it in Java from scratch, and usually, yeah. This is kind of long and I'm kind of tired, so yeah, just that's one thing you could do. Like if you see a solution in C++ and you're doing Java, some people posted like I code in Java, people post Python solutions. Just take their solution, GPT convert to whatever language. It's a pretty good use case of it. Also, what you can do is if you have messy code, you can GPT and ask it to clean up your code to make it look a little bit better. It's also a good one. Okay, so basically we have our positions and we have our robots. And like I said, for every robot, you have the position, the health, the direction, and the original index. And then you sort based on position. Then we have our stack. Then for every robot, we're going to get the position, health, and the direction and the index. If it's right, there can't be a collision, so we just add it in to the stack. Otherwise, if it's left and we have a stack and the last item in the stack is right and the current health of our current guy is greater than 0, which means it's still alive, we check, is our health of the left guy that we're currently on greater than the last guy? If it is, then we're going to pop from the stack and then minimize, we're going to lower the health of our left guy by 1. Otherwise, if the health is less than the last guy in the stack, then the last guy in the stack will lose 1 health. And this guy will die. So this guy dying, I just say health equals 0 of the current guy. Otherwise, they have the same health, so you just make the health 0 and remove from the stack. They both kill each other. Then at the very end, you check, is the health of your current guy non-zero? And if it's non-zero, that means your current guy is alive, so you're going to need to add it to the stack. Then we have a survive bots list, and it's pretty easy. So we're going to sort. So we're going to have a stack, and remember our stack is health. So each item, it's like a stack of these things, right? Health, direction, original index. So we want to sort based on original index. And then that way they'll be in the same order as they came into the function. And then we just take all of those and append the health, and that's basically it. So sort your stack in terms of original index, and then just write all the healths out into your result and return it. And that's basically it. So yeah, I remember doing this during, I think this was actually the last promo of LeetCode contest. Definitely a lot easier than most. Like top 10% easy, I'd say. Oh yeah, and people wanted me to list the companies. So I can either do one of two things. Let me know which one you prefer. I can either just show it here, or I can take the images of the companies and put them in like the picture. Some people do that. So whatever you prefer, just let me know. Yeah. And let's go through the time and space and all that. Okay, so these are all the same length, so we'll just call this O of n, like this is n, n, n. So we basically make a new array, and then we sort it, which is n log n. Then we go through our array, and then we sort it again. And then our stack can't be bigger than our original array of robots, so that's just n log n total. So this is just n log n. And then we have a stack, and we also have the array of robots, so both of those are O of n. So this is n log n O of n. Let's see if it's correct. Okay. Yeah, and then I wanted to make like a small announcement. So I don't know if I'm going to keep doing the LeetCode contest videos because I try to actually do some work stuff during the weekend. I might. I'm still probably going to do the problems, so I might just like post the solutions somewhere, but not do videos. I'll see how it is. And then I wanted to do more videos on actual like industry stuff that you run into. So like I ran into a bunch of issues at work that were like kind of hard for me to solve. I had to ask a bunch of senior people. So I might start doing that, like some things that, you know, aren't taught to you at like a boot camp or CS or whatever that you kind of learn the hard way. And they're pretty common and they're kind of good to know. So I might make actual like software videos as opposed to like only LeetCode. So let me know what you think about that. And yeah, it's going to be all for this one. If you liked it, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.